Hi everybody, welcome to our new unit, which is graphing linear inequalities. First we will start out with just graphing one inequality, and then later in the week or next week we will start graphing systems. This is a pretty quick unit compared to the other units we have been in. There's only 2 topics to really cover. So our first video is graphing these. Remember, this right here is slope, intercept, form. Okay, so graphing a linear inequality, remember our inequalities are greater than, I'll write that there, greater than, didn't leave myself much room, less than, we have less than or equal to, less than or equal to, and then greater than or equal to, greater than or equal to. Okay, so when you are faced with a problem like this one right here, number 1, y is greater than or equal to 5x plus 4, I always tell my students when they're sitting in front of me that that's your thought bubble, and you want to think of this as just, well, before I worry about the inequality, how do I graph the equation y equals 5x plus 4? And remember, like I just mentioned, this is in slope-intercept form, which we practiced for a long time before we left in March. Y equals mx plus b. So like I've mentioned before, I don't have graph paper here at home, so here I go. So looking at this equation, notice this isn't anything new. I'm not doing anything new yet. We've done all the steps I'm about to do if this thing would just focus. My b, my y-intercept is at 4. So I go to the y-axis, I put my first point at 0, 4. My slope is 5 over 1. So remember, slope is m is equal to rise over run. So that means I could go up 5, 1, 2, 3, 4, 5. Remember, up 5 from the point you're at, so 1, 2, 3, 4, 5. And then I could go to the right 1. You could also go down 5 from your 0, 4, so down 5, 1, 2, 3, 4, 5. And then to the left 1. You guys were really good at that when we did it in class. Okay, so before, those of you working in pen, before you connect these points together, when we are doing inequalities, there are 2 things you need to remember. One of them is, how do I want to circle this? If I have just greater than or less than, that's going to be a dotted line or dashed line, and I'll talk about what that means in a minute. If I have less than or equal to or greater than or equal to, that's going to be a solid line, and I'll talk about what that means in a minute too. So because in my problem I had a greater than or equal to, that means I'm going to have a solid line. So you're just going to draw in your line just like you always have. And so you might be like, well, how's this any different than what we've done before? Just give me 1 minute and I will finish the problem. But so a solid line means that any point on that line would be a solution to the original inequality. So let's take this point, 0, 4, just to show you something. So I'm taking the point 0, 4, and I'm showing you that it would be a true statement if I put 0 in for x and 4 in for y in the original inequality. So 4 is going in for y because 4 is in the y spot. 0 is going in for x because it's in the x spot. So I get 4 is greater than or equal to 4. That's true. It's not just that one point that works, it's any point on the line. And remember, lines go on forever. So any point on that line would work. If, just to have a side conversation, if this was a dotted line, and let's say it was just y is greater than 5x plus 4, just to show you this. 4 goes in for y, 0 goes in for x. I'm going to end up with 4 is greater than 4. Is 4 greater than 4? No. 4 is equal to 4. So on a dotted line, where it is a greater than or less than symbol, any point on the line is not a solution to the inequality, meaning that it doesn't work. Okay, back to the problem. So we have our line, and the only extra thing that we now have to include is a shaded area. And you are either going to be shading to the left, or some people see that as above the line, or the other side, as I call it, is to the right or below the line. And to figure that out, I encourage you to test a point. I like to test 0, 0, because 0 is like the easiest number to substitute into any equation or inequality. I can use 0, 0 because the line does not pass through 0, 0. If the line went through 0, 0, I would not be able to use it as a test point, and I'd have to pick any other point. Try not to pick a point really close to the line drawn. So what does it mean to test 0, 0? It means you're going to take the original problem, and I'm going to put 0 in for x and 0 in for y, and see what type of a statement I get. So I'm going to get 0 is greater than or equal to 4. Is that true or false? You're going to tell me that's not true. 0 is not bigger than 4. So 0, 0 is right here, which is to the right or below the line. Because this was false, that means 0, 0 is not a solution to this problem. It also means that any other point to the right of the line would not be a solution. You could sit here all day and pick any point to the right of this line and it wouldn't work. So what that means is when I come out with a false statement like this, it means I have to shade the opposite side of the line. So in this case, I'm shading to the left of the line. And again, this would go on forever and ever and ever and ever, but that's enough to draw in. And so your answer to these types of problems is the actual graph. This graph that you see right now is your answer. The solutions to this problem, like we just talked about a couple minutes ago, in this case is any point on the line and any point in the shaded region. So let me ask you this. How many solutions are there to these sorts of problems? These types of problems? No one? Anybody? There are infinitely many. I will make the next problem less crazy. I just had to kind of set this up.